Alright, this is the unit circle. Now what is the unit circle? To put it simply, the unit circle is just a circle of radius 1. And it's important to remember that the circumference of a circle of radius 1 is just 2 pi. Because the circumference is equal to 2 pi times the radius, which in this case is 1. Now, what do we use the unit circle for in pre-calculus? We use it to determine the x and the y coordinates using the sine and cosine function. This is normally done at key locations like 0, 30 degree, 45 degree, 60 degree, and 90 degree, and the multiples of all the way around the circle. You can also calculate the tangent value by dividing cosine by sine, and that gives you the length of the tangent line from the circle to the axis. When dealing with the unit circle, we use a different system of measurement than what you're used to. If we would call this degrees, then this would be the radians. And as you can see here, just like a circle has 360 degrees, it has 2 pi radians, the same as the distance of the circumference. Now, if you take a look at this circle, you'll notice the 0 point is at the far right side on both of these. That's because on the unit circle, we start on the far right side and move counterclockwise around. You also notice that only key locations are marked on it, the 0, 30, 45, 60, 90, and the multiples of that. The 30 degree corresponds to the pi over 6 location, 45 is pi over 4 radians, and 60 degree is pi over 3 radians, 90 is pi over 2. We'll be working pretty extensively with radians in this class, so it's going to be very important to memorize the values of these positions around it, just like you know the values in degrees. The quadrants on the unit circle. The quadrants have a special significance. We have quadrant 1, 2, 3, and 4. And what we know from this is a sign for the x and the y values going around it. In the first quadrant, x is positive and y is positive. In the second quadrant, x is negative and y is negative, or positive, sorry. In the third quadrant, x is negative and y is negative. And the fourth quadrant, x is positive and y is negative. So there's only a few values on the actual unit circle, so it's very important to understand the sign changes, because if you know the few values that there are, all you have to do is swap the signs to understand what the values are in the other positions. The common values and positions on the unit circle. So, in radians, we start with 0, move counterclockwise around it until we reach the 2 pi location. It's easiest to think of this in terms of two different halves. The 0 to pi or half, and the pi to the 2 pi half. And each of these halves you can divide into 6 and 4s. The 6 are shown in red as well as purple. So we have the 0, pi over 6, pi over 3, pi over 2, which is 2 pi over 4, 2 pi over 3, which is 4 pi over 6, and 5 pi over 6, and pi. For the bottom, you can see the other points shown in red. In the fourth, we have the 0, the pi over 4, pi over 2, 3 pi over 4, and pi. and so on all the way around the rest of the circle. Students sometimes get tricked up because of the change in the denominator, but it makes a lot more sense if you think of it in terms of 6 and quarters around each half, because if you just multiply these reduced denominators, you'll understand that it's just counting. 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi, and all the way through the bottom half as well, all the way until you reach 2 pi, which is 12 pi over 6. You can do the same thing for the quarters as well. We have 0, pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, until we go all the way around to 2 pi, which is 8 pi over 4 as well. It's going to be important to get used to these. Measuring angles on the unit circle. You're used to understanding degrees as the way that we measure angles, but in this class we'll be dealing heavily with the radian measurement system. So we have 0, 360 is the start point, which should be the first thing that sticks out to you. We start at the far right side of the circle on the unit circle. We move from 0, 30, 45, 60, 90, and all the multiples of for each of the individual quadrants. You can see it's shown here, the corresponding values for each of them. 30 degrees is equivalent to the pi over 6 in radians. 45 is equivalent to pi over 4 radians. 60 is pi over 3 radians. 90, pi over 2. It is going to be important to get very used to these values in radians, just like you're familiar with the values in degrees, because it will be referenced often in radians, and your values will have to be calculated in radians as well. So you'll have to understand which position we're talking about when the radian location is called out. Now here's the full unit circle. You can see here the x and the y coordinates are given for each location. If you notice, there's actually only a few values: 0, 1, square root 3 over 2, 1/2, and square root 2 over 2. All the other values are the same, just different sign changes for the different positions. You can see, like we said before, all the values for x and y are positive here. All the x's are negative in quadrant 2, the y's are positive. In quadrant 3, both are negative, x and y. And in quadrant 4, x's are all positive and the y's are all negative. This is the 0, 2 pi location. These are the values that it helps to memorize these, because without memorizing them, you really won't be able to understand how to do the problems. But since there's only 5 values and each of the points correspond to another point, it should make this not too much of a problem. Let's take the 45 degree and its corresponding angles as an example. So if we go all the way to the 135, all the way down to the 225, over to the 315, and then up to the back up to the 45, let's look at the values of those. All of the values are square root 2 over 2, but with different signs. In quadrant 1, they're positive. 2, the x is negative. 3, they're both negative. And in 4, one of the y is negative and the x is positive. This is true for all of the values going around it. They all correspond, and they've been shown in their individual colors which points each of them correspond to. They each make different sized rectangles or a square. Now, to show how this is used and the type of problems that you end up doing with the unit circle, we'll go over a few examples. Cosine of pi over 6. Cosine of pi over 6, which if you had memorized the previous slide, you would understand is square root 3 over 2. Sine of 3 pi over 4. That would be the 135 degree location. We know that y is positive because it's in quadrant 2. It is square root 2 over 2. Cosine of 7 pi over 6 can be found right here. It's in quadrant 3, and it corresponds to the pi over 6 location. So just like the top, it's square root 3 over 2, but the sign is changed because it's in quadrant 3. Sine of 5 pi over 3 corresponds to the pi over 3 location. In the pi over 3 location, sine is equal to square root 3 over 2. But since it's in quadrant 4, we know that the sign is negative. Now this can be tricky. We can have negative values in radians. So if I said cosine of negative pi over 3, that would mean that we're going clockwise now. So if the pi over 3 location is up here, the negative pi over 3 would be equivalent to the 5 pi over 3 location. So this, since it's in quadrant 4, would be 1/2. Sine of negative 5 pi over 6. 5 pi over 6 is here, but that would be if we're counting clockwise or counterclockwise. If we go counterclockwise, it would be the same as the 7 pi over 6 location. And the sign of that point would be negative 1/2. As you can see, I didn't do any math to solve for these values. That's because it's very important to memorize these values from the previous chart. But as I said, there's only 5 different values and different sign changes for each of them depending on the quadrants there are. And each point has a corresponding point to it. Generally, as you go on, you won't be given this diagram to easily locate the points on it, which is why it's so important to understand the measurements in radians just like you do in degrees. Once you do this, it makes solving for these much more simple, and it really is the base for what all pre-calculus works with. Radian measures become very common, and it becomes something that you really need to know by heart. It'll take some work, but you'll get used to it.